Bismillahirrahmanirrahim. This is our first lecture after midterm examination. Previously we have covered the basics of BJTs and FETs and their biasing circuits. So before their use as an amplifier and before studying their small signal models, we have to cover some fundamentals of amplifier. So what is an amplifier? An amplifier is a device that is used to boost the input signal in a specific way, whether the input signal is a direct voltage or in any other form like a voice signal, etc. So there are some basic amplifier characteristics which is common in our type of amplifiers, whether they are voltage amplifiers, current amplifiers, or power amplifiers. All of these type of amplifiers have some characteristics in common, which are basic characteristics for all types of amplifier. So as you know, a voltage amplifier will amplify a voltage signal, a current amplifier will amplify a current signal, and a power amplifier will amplify a power signal at the output of the amplifier. So what are the basic amplifier characteristics? Number one is input resistance. Number two, voltage gain. Number three, current gain. Number four, output resistance. Number five, power gain. So first we will define all of these characteristics for an amplifier. So consider an amplifier to be a two-port network. Like this, with input and output ports. So when you connect a voltage source at input side, which will be Vi, let's say the input current is I, and if we connect a load across the output voltage is VL and the output current is I0. So remember, we will use lowercase notation for AC signals and uppercase for DC signals. So this is a case of a loaded amplifier in which we have connected a load across the output terminal, and you can see that the input current direction is from negative to positive, or the input current is leaving the positive side, and also the output current is leaving the positive side of load voltage. So you can see their direction is opposite, so in this case we can anticipate that the current gain will be negative. So first of all, we will go towards definition of input resistance. Input resistance is simply the resistance seen at the input side of an amplifier, just like this. So if you are measuring the AC input resistance, this is Ri, the AC input resistance. The small r is used for AC, and the capital R will use for DC input resistance. So Ri is simply the ratio of Vi and input AC current. Input AC voltage divided by input AC current is equal to input resistance measured at the input side. Similarly, the DC input resistance, shown with the capital letter, will be equal to Vi over I input. This is AC input resistance, and this is DC input resistance. So next we will define the voltage gain. For an amplifier, the voltage gain, shown with the letter A subscript V, is equal to simply the ratio of output voltage over input voltage. And if the output voltage is out of phase with respect to the input voltage, then there will be a negative sign with the voltage gain. Next is current gain. The current gain with the subscript I is simply the ratio of output current divided by input current, and if the direction of both current is opposite, then there will be a negative sign with the current gain. And there is an output resistance. Output resistance is usually measured at the output terminals are not, and this is actually the Thevenin resistance measured at the output terminals. So you can measure the Thevenin resistance at the output terminal by using two methods. The number one is you connect an external source. So in this case, when you connect an external source, and then you will short the voltage source on the input side. Here the R naught will be equal to V external, which you have connected, divided by I external. The second method is to simply measure the open circuit voltage at the output side and divide it with the short circuit current at the output terminals. So the R naught in this case will be equal to V open circuit divided by I short circuit. So in using these two methods, you can measure the Thevenin resistance at the output terminal, which is actually the output resistance of an amplifier. So the last characteristic is for amplifier is power gain. So the power gain is simply measured using the ratio of output power divided by input power. So the output power is basically V naught multiplied by I naught, and input power is Vi into I input. So by putting these values, the power gain will be equal to V naught I naught divided by Vi into I input, simply the ratio of the so this will be equal to the product of voltage gain and current gain. You can also use other formulas for input and output power, like input power is equal to I square into Ri, or Vi square over R input. So in this way you can measure the power gain for an amplifier. So after covering the amplifier characteristics, we will derive a general formula for voltage gain for the two-port network described previously. So this was the two-port network. So in this case, the input voltage can be written as the product of input current and input resistance, and the output voltage VL, which is actually the load voltage, this can be written as the product of RL and I naught. But remember that if we are comparing the direction of input and output currents, they are in opposite direction, so we will take the output voltage as product of minus I naught and RL. So in this case, the voltage gain formula will be V. First of all, the input voltage is equal to input current and input resistance, product of input current, input resistance, and output voltage VL is equal to product of minus I0 and RL, because I0 and I input are in opposite direction. So the voltage gain will be equal to VL over VI. We are taking VL because this is the case of a loaded amplifier, otherwise we have taken V0 minus I0 RL, I input RI. This is current gain, so minus AI into RL over RI. So this is a general expression for a loaded voltage gain, and it is common for all type of amplifiers regardless of their structures. So this shows that you can measure the voltage gain, the loaded voltage gain for an amplifier by simply multiplying the current gain and the ratio of output resistance and input resistance. Next, we will solve an example which will cover many concepts regarding basic characteristics of an amplifier. So the given amplifier has current gain of 80. This is the symbol we will use for an amplifier. The output has a load resistance and the output voltage is equal to 0.4 VRMS, and this is the direction of output current. At the input side we have VIT, the AC voltage, and input current. The input voltage is basically a combination of a DC bias voltage on which an AC is superimposed. The DC bias voltage value is 0.7, so VIT is equal to 0.7 plus 0.008 sine of 10 raised to power 3t. This is VIT. And the input current has DC bias voltage of 2.8 into 10 raised to power minus 5, and the AC current value is 4 into 10 raised to power minus 6. This is peak value, IP, into sine of 10 raised to power 3t amperes. And the AC output voltage is equal to 0.4 VRMS. So we have to find voltage gain, DC input resistance, AC input resistance, output current and or its RMS value, load voltage and power gain. So first we will measure AV. For calculating the value of voltage gain, we have to find the RMS value of input voltage, because in a ratio both values should be in the same form, either in peak value or RMS value. So V input RMS will be equal to 0.707 into Vp, or peak value. So what is the value of Vp? It is 0.008. 0.707 into 0.008. This is equal to 5.66 into 10 raised to the power minus 3 VRMS. Okay. So now the voltage gain will be simply equal to V naught RMS to VI. 0.4 divided by 5.66 into 10 raised to the power minus 3, that is equal to 70.7. So this is voltage gain for this circuit. The next value we have to find is input resistance, which is DC input resistance, and it is equal to ratio of DC input voltage divided by DC current. DC input voltage is 0.7 and DC input current is 2.8 into 10 to the power minus 5. Or it is actually equal to 2.8 into 10 to the power minus 3. There's a mistake. This is equal to 2.8 into 10 to the power minus 3. So BI is simply 0.7 divided by 2.8 into 10 raised to the power minus 3 ampere. This will be equal to 25 kilo ohms. This is DC input resistance for this amplifier. The next we have to find is AC input resistance. AC input resistance will be equal to VI over I input, AC input voltage divided by AC input current. So either we can use the RMS or peak values. So the peak value of input voltage is 0.008 and the peak value of input AC current is 4 into 10 raised to the power minus 6. This is equal to 2 kilo ohms. Next we have to find the value of output current and or its RMS value. So this will be equal to current gain multiplied by the RMS value of input current, as the current gain is equal to ratio of output current and input current. So by putting the values, the current gain is equal to 80 multiplied by the RMS value of input current is equal to 0.707 multiplied by peak value, which is 4 into 10 raised to the power minus 6. So this will be equal to 0.226 milliampere RMS. Next, we have to find the value of RL. So the output or load resistance in this case will be equal to output voltage divided by output current. You can use RMS values or peak values. As we have find I naught RMS, so we will use RMS values. So V naught RMS is simply given, which is 0.4 VRMS divided by I naught RMS is 0.226 milliamperes. And this will be equal to 1.77 kilo ohms. In the last, we have to find the value of voltage gain, which is equal to output power divided by, this is actually small p, input power. So first we have to find the value of output and input power. Output power will be equal to V naught RMS whole square divided by R naught. V naught RMS is 0.4, and we have find R naught, which is equal to RL in this case, and its value is 1.77 kilo ohms. That will be equal to 9.04 10 raised to the power minus 5. Next is input power, VI square RMS divided by RI. The input RMS is equal to 5.66 into 10 raised to the power minus 3 square divided by input resistance, which is equal to 2 kilo ohms. This is equal to 1.6 into 10 raised to the power minus 8 watt. So simply the power gain is equal to 9.04 into 10 raised to the power minus 5 divided by 0.6 into 10 raised to the power minus 8. This is equal to 5650. Or you can find the power gain using this formula. AP is equal to AV into AI, which is equal to 70.7 multiplied by 80. This is approximately equal to 5656. So there is a minute difference in these values due to rounding of error. So this is up for today. We have covered the amplifier characteristics, and we have done an example which shows that how we can find the basic values for an amplifier. Next we will in the next lecture we will inshallah learn the amplifier models, different models for the amplifier. So this is up for today.